Hello guys, welcome back to my YouTube channel, Ruby Structures. If you're just joining us for the first time, please do well to subscribe to this channel. Please, if you find this video educative, don't forget to like. Also drop comments on more videos you would want us to do. And also do well to share this video to your colleagues, your friends who might want to design the retaining wall using ProtaStructure. Okay, so let's go right into it. The first thing we are going to be doing is you open your ProtaStructure, the ProtaDetails to be exact. You come to your design library and you come to Cantilever retaining wall. So ProtaStructure or ProtaDetails allows you to only design the cantilever type of retaining wall. You know, there are a lot of types of retaining wall. There's the cantilever, there's a gravity wall, there's buttress and all of that. But ProtaStructure allows you to design the cantilever retaining wall. So once you click on it, the menu comes up where you want to design your retaining wall. So you have to change some parameters. So total height, okay, total height of a retaining wall, you're going to leave that as 5,000 because that's the total height we're going to be using for this retaining wall. All right, so h1 is h minus T1, that's the value for h minus T1, and T1 is about 400, so h is 4,600. Okay, so the casting height, number of casts, you want to leave that as 5,000. And our wall height, wall length, the length is not the height of the retaining wall, it's more like how wide, okay, how wide or how long your retaining wall, the span is going to cover. Okay, so our retaining wall is going to be spanning 10 meters. Okay, so stem, top width, you have your stem. A is the stem, the top stem, while B2 is the bottom stem. Okay, so for our A, we are going to be using A of 300. E, we don't want this to slant. For this design, I wouldn't want to have a slanting stem. All right, so my E, I have to eliminate that, so I'll just click 0. Okay, and that is it, 0. All right, so my B1, I want my B1 is my toe. The short part of your base is usually called the toe, while the longer side is the heel. So the toe, I want the toe to be about 900. Press enter. B2 is the bottom stem, the bottom width of our stem, so we are going to be giving that as 300. Our top and bottom stem, we want to keep it the same. Right, we want to keep it to be the same. Okay, so our base plate back length, okay, the back length, that's the heel. The heel of it is going to, we are going to keep the heel as 2,000. Okay, at 2,000. All right, so we have done with the geometry, so we can come back for the base plate. Okay, so if you look at this orientation, here, you will realize that for the toe, it's kind of tapered. All right, it's tapered. You have the T1, that's the short, and the T2 and the T1, so it's kind of tapered, but I don't want that to be the case, so I want it to be straight throughout. So for this design, we're going to click here. All right, so we can keep it the way it is, like this. All right, so the thickness is 400. So in case you have a design and you want to include share key is more like an addition, okay, to the base of it, in order to just to give it more rigidity, understand, to prevent overturning. And if you're restricted, in certain cases where you're restricted for your base width, you could add a share key in order to help that, but then this time we don't want share key, so we can just untick that. And in cases where you have parapets, like a little concrete or a little wall on top of your retaining wall, okay, you could use this, all right, but then we don't have a parapet. Also, if you have a case where you have a retaining wall and there are levels, okay, levels with, maybe there's on the retaining wall you want to add a small cantilever, like a shelf, yes, call it a shelf. So you could do this if you want a single shelf, and if there's a possibility of having a double shelf, you could also do this, but for our design we are not going to be doing that. Okay, So that is it for our geometry. Also remember that we could size this. It's possible to make sizing for your retaining wall using the thumb rule. Okay, that I will not be expatiating on that right now, but so in my subsequent videos, in my manual design of the retaining wall, I don't have the video right now, but subsequently I'll be uploading a video in the manual design where we can have a thumb rule to predict from the height of your retaining wall, where you can predict the dimensions, the minimum and the maximum dimension you should go for your heel and your toe and your base and all of that, even your stem thickness. But now we are just, since we are using a software, we are just imputing values. Okay, next thing you're going to come is going to come to your soil parameters. Okay, so you have cohesive soil. For the ground soil is being ticked. If you tick it, it means that whatever soil you're going to use for your backfill is going to be a cohesive soil. But we are going to untick this because we are going to be using a non-cohesive soil for our front fill and also a non-cohesive soil for our backfill. But we are going to be having a cohesive soil for our ground soil. Okay, so for the dry unit weight, this can be gotten from your soil report. Your dry unit weight is a function of the type of soil you're using or the type of soil available. Alright, so we can get this from your soil report. Now if you click this, you could see that for a topsoil natural condition, dry unit weight is about 17 kilonewtons per meter cube. For a sand or a gravel moist is about 18. For a sand or gravel saturated is about 20. Okay, so your soil report should be able to give you a unit weight. Okay, so it's a function of the type of soil. Your dry unit weight is a function of the type of soil. Also, your saturated unit weight is also a function of the type of soil, and this can be also found in your soil report. Very, very important when you're designing structural components that has to do with that is going to be in the soil. Soil report is very, very important. Okay, so soil unit weight, also the saturated unit weight, is also a function of the type of soil you're going to be using. And you know, there's also a relationship between your dry unit weight and saturated unit weight if you check, but that I won't be talking about that right now. Okay, so also effective internal friction angle, same thing, is also a function of the type of soil you're using, and this can also be found on your soil report, but we're going to be leaving this at 36 degrees. And also effective wall friction, this, and effective cohesion for ground soil. If you tick this to have a cohesive soil, you will have to add that, and all of this can be gotten from your soil report, but then we are going to be using a cohesiveless soil for our backfill, so we can untick that. Next thing, the ground soil, you're going to be using soil bearing capacity. The soil bearing capacity we are going to be using for this design is 120 kilonewtons per meter square. It's going to be about 120 kilonewtons per meter square. Okay, so our base friction coefficient, same as a function of the type of soil you are using. All right, so that is it. Okay, so next thing, you're going to come to a few parameters. We have a few parameters. So we have a front view and we have a back view. Okay, so for our front view and back view, our front view is HP and our back view is HA. Front view is HP and our back view is HA. So our front view, we're going to be having a front view of 1500 for this our design. Okay, we're going to be having a back view, we're going to be filling the back to the top, so the back fill of 5000. You know, the total height of our retaining wall is 5000, so the back fill height is 5000. So height of water table, depending on your soil report, where you have your groundwater table, depending on your soil report, you could have that from, by default is 0 for the front view and about 1000 for the back view. So but then depending on your soil report, for this our design, our groundwater is about 500 for our front view, and you see, once we change to 500, there's HW, right, for our groundwater table. And for the back view, we're going to have it as 1000. Okay, we're going to have it 1000 for this design. So the soil slope angle, if we change this, for example, and we keep it at 30 and see what happens. Okay, you see the soil slope for areas where you have like a slope. Okay, you could actually include the slope so you can see the slope of the fill material. Okay, but then fill for this cantilever is going to be 0, so we can just leave that at 0 for both the front fill and the back fill. So the magnitude of distributed surcharge, this can also be found on your soil report, please, on your soil report. So, but then for this we're going to just keep it at the default as 2.50 kilonewtons per meter square for both the front fill and the back fill. So the distance of the distributed surcharge for the front fill, distance is close here. For the back fill is about 1,000, but for the back fill, I'm going to be leaving this as also going to keep the surcharge close to our retaining wall. So the length of the distributed surcharge, the length for the front fill is 3,000 and this is 1,000. You could leave that as that. Okay, so we come to our analysis settings. So as stem effects, include effect of stem front face slope on soil pressure. Yes, you can tick that. Include effect of stem back face slope on soil pressure. Yes. So for the passive side effects, you want to include passive pressure of the soil in overturning and sliding. So we don't, if you need it, you could just tick this, but for this design we will not be doing that. So include few weights. So okay, so leave that. So for others, include positive effect of surcharge. All right, and also yes, I also want to include the positive effect of addition in sliding stability. I also want to include that, so you can just tick that. Okay, so for a dynamic effects of self weight, so I want to include it. Okay, I want to include that, to include in all calculations. All right, I want you to include in all calculations the stem weight, base plate and fill. Okay, all right, so we can come to our design settings. So our parameters, if you want to use the stem front face splicer or you want to use the stem back face splicer, you can use that. So for our rebars, we are going to be using maximum spacing of our rebar is going to be 200, maximum spacing for going to be 100, and okay. So for our materials, in case you have a concrete, you could change this for a better concrete, but I'm going to be using C2025 grade. I'm going to be using a 410 type 2. So for diameter of bars, okay, for diameter of bars, we'll be using Y12 and Y16. So this is wall, cantilever is a wall, so we can just edit that to make sure it's Y12, Y16 and Y20. Okay, Y12, Y16 and Y20 is what we want to be using. Okay, so we could just, in case some of this isn't needed, okay, so you just leave it like that, Y12, Y16 and Y20. So you could just click OK for it. So come to code settings. So the code parameters, concrete cover of 30. I want our concrete cover to be 50. Okay, and also what code are we using? I'm going to be designing to Eurocode. In this design, we are designing to Eurocode, and okay. So for the earthquake parameters, you could edit it manually. Okay, soil report and all of that, and you can just leave it like this. Let it be the default from the code. Okay, so this is just the factor of safety. So Eurocode, the overturning safety dynamic is always 1.0, the sliding effect is 1.0, failure safety 1.0, soil bearing capacity coefficient to dimension. So you can just leave this as this. So analysis summary, this is the loads calculated. All right, so this is the load calculated. Total failure, so this is the overturning, you see it. So you can come to design. All right, so we have done a design. Okay, so what it's telling us is that the maximum allowable bearing is not satisfied, and the maximum allowing bearing minimum and maximum is not satisfied. but the design is successful. What this means is that the soil bearing capacity is low, and our base, we need to increase the base. So what we can just do is that we come to our geometry. Okay, so we have the base, so we can just increase this, keep this as maybe 1100. Okay, we keep that as B1 1100. So B2 we can just increase this to 2500. Okay, keep it at 2500, and T1 can just increase this to about 500. Okay, we increase that to 500 and we design it again. Okay, so what it's telling us, is telling us the maximum liable bearing is also not satisfied. It's still not satisfied. So this is because of the bearing pressure we had about 120. Okay, so if that's the case, because of that, we could just keep on increasing it and making sure that that's the case. So we can just change B2. Let's change B2 to 400, change A to about 400 too. Okay, so if we increase this to, let's just say 3000, okay, and increase B1 to 1500. Okay, so when we come back, bearing pressure, once your soil bearing capacity is low, it needs a wider spread. Once you have a low bearing capacity, you need a wider spread of foundation. That's what it's just trying to tell you. So before, our spread was a little bit small, but now we have increased our spread to, you see, B1 is about 1500, this is 400, B2 is 400, and B3 is about 3000. So that's a combination of almost 4900. Okay, so we can come back to design. Okay, so what tells that the stability analysis are successful and also the design is successful. That means what we have done, the geometry we went to change, is successful, and this retaining wall passes. Right, so we can come to the stem to check the detailing. So what it provided, that it provided for the vertical, provided 51 Y12 for this, for the short side, for this side that is closer to, yes, the front view. Front view provided 51 Y12. So but the back view, it provided 91 Y16 at the spacing of 110. For this other side, it provided 61. But then if you want to reduce this, the spacing, you could also just increase the thickness of your stem. Because if you increase the thickness of your stem, you could actually reduce the spacing to about 150. Okay, but then this also works if you have the reinforcements to use. Okay, or probably you could just change it from, okay, not 100, you can just, maybe you could just change Y16 to Y20. Let's see, change to Y20 and it passes. Okay, change Y to Y20 and it passes. Okay, same with this, you could change, okay, leave that passes. So you see it works. You could just change and play with it as you would want to play with it. So we have increased it to Y20 at 150, and it's about 67, that's given at 150. 67 Y20 at 150. Same with the base plate. So for the top reinforcement, is giving Y20 at 100 spacing. Alright, for both the S2 and the S3 side. Okay, for both the front fill and the back fill. And for the bottom is giving Y12, 72 Y12 at 140. Okay, we could just, as I've said earlier, we could increase this to Y16 and increase this to 200 and see if it works. Okay, see if it works. I think it works. It works. Right, so because it's still green, that means it works. All right, so that is it. You could come to your report as you would want your report to look like. You just come here, then you generate your reports. Okay, but then if you want to prepare a working drawing for your retaining wall, you could just come here, prepare drawing, click anywhere. As I've said earlier, click anywhere on your drawing sheet and you zoom in and you would see the detail. Right, so this was the height, about 1500, the height of our front view, right, and the height of our back view was 5000. As you can see, this is the height of our back view. Our stem was 400, so the base we had 4900. You see it, 4900 for the base. Okay, So 5 centimeters is like 50 mm laying concrete. That's the blinding. 50 mm. Okay, so this is the reinforcement. This is the detail for the reinforcement, both the vertical and the horizontal reinforcement. You see Y12 at okay, so this is the reinforcement it's providing. Okay, for the vertical. So for the horizontal is Y12 at 200, for the vertical Y12 200, and also this other side is Y20 at 150. Same with also the base. Alright, please don't forget, see the orientation of the bars, how the bars are being placed. You see the one for the front face is bent into the side of the back view. Okay, so please, this orientation for reinforcement on site is very, very important. Okay, so we have come to the end of our tutorials on design or retaining wall using ProtaStructures. Please do not forget to subscribe to our YouTube channel, like this video if you found it very educative, and also subscribe. Thank you. Share this video to your friends who also want to learn. Thank you very much. See you on the next one.